Hello everyone, my name is Jessica Perez and today I will be explaining to you Chapter 3, Problem 26 from the book. So the problem states, the 23 kilogram pipe is supported at A by a system of 5 cords. Determine the force in each cord for the equilibrium. So first we have to identify our givens, which would be the weight of the pipe, which is 30 kilograms. And then we're also given the angle at line AB, which is 60 degrees. And at line BD, we can see that there's a 3, 4, 5 triangle. And then after that, we can move to step 2, which would be to find the force in each chord for the equilibrium. Step 3 would be to make assumptions, and I assume that one must use sine and cosine to find the force on each chord. Step 4 would be to make a plan. So step 1 would be find the sum of the forces for X and Y at H, A, and B. You would look at these points because these points are the main points holding up the rod that isn't connected to the wall. And due to it being at equilibrium, you must set it equal to 0. Then step 2 would be all tension forces created at H. You gotta find them. And those are like the points that are connected are touching that area of H. And you would repeat step 2 for A and B and list all the tension forces. Step 5 would be to make a free body diagram, and we made 3 free body diagrams, one for H, A, and B. So the first body diagram represents H and how it has the tension pulling upwards and the gravity pulling it downwards. And then the second body diagram represents the tension from the pull between A and B at 60 degrees and the other tension from the wall of A and E, and also the force of gravity pulling it down. And the last body diagram represents B, where it is showing the tension from BD, BC, and BA, the 60 degrees, and from BD you see the 3, 4, 5 triangle. This then moves us to step 6, which is the solution process. For the first one, H, we see that there's no X components involved, so we only solve for the Y component, which because it's at equilibrium, it will be equal to 0. So we get the tension from HA minus the weight times gravity, which equals 0, and that results in the tension of HA equal 294 newtons. For A, the sum of the forces for Y equals 0, because it's at equilibrium again. It will be at equilibrium for all of them. So the tension of AB times sine 60 minus the weight times gravity again equals 0, which results in 340. The same thing for the X component, and that results as a 170. For B, the Y component, the tension from BD equals 490, and for the X component, that tension from BC equals 562. And that is how you solve this problem. So thank you for following along and have a great day.